Hello Year 12, welcome to your first personalised video. Okay, and in this first video we are going to be looking at a little rule that we can use when we are integrating something that looks like the integral of a times f of x, where a is a constant. Okay, and the rule that we're going to be using says the integral of a f of x dx is the same as a times the integral of f of x dx. Okay, so basically all the rule is saying is that if you have a constant inside the integration, you can pull it outside the integration as a multiplication. Okay, so this is an important rule that you need to know, so write it down somewhere, put it in a big red box and remember it. Eric, are you listening? Okay. Alright, so let's look at a little example. So let's just get my blue pen. Let's say we wanted to integrate 12x dx. Okay? And we can do that as we already have learned how, which would go to 12x squared over 2 plus a constant of integration. Do a little bit of cancelling. 2's into 2 go once, 2's into 12 go 6 times. So the answer is 6x squared plus our constant of integration. Okay, so that's easy. That's not using our rule. Let's have a go with our rule. So let's shrink this, check this technology out. Pretty cool. Okay, and let's do it again but using our rule. So the integral of 12x dx is the same thing as the 12 comes outside the integral as a multiplication, so the integral of 12 times the integral of x dx, okay, which is going to be 12 brackets, well, we know that x integrates to x squared over 2 plus c, which simplifies to 12x squared over 2 plus 12c, which simplifies to 6x squared plus 12c. Okay, but over here we had an answer of 6x squared plus c. So it looks like something has gone wrong until you remember that the constant of integration is an unknown value. We don't know what it is, it's just any old number. Okay, so if we're saying the answer is 6x squared plus some number c, or 6x squared plus some number 12c, actually it's not going to make any difference. And if I instead say over here, well, let's say that 12c is actually something new, maybe d, then our answer, shrink this down again, is actually just going to be 6x squared plus d. Okay, so we've got two answers, 6x squared plus c, 6x squared plus d. Really, they're just different letters. Okay, I could even have just written here c and not even worried about the 12. Because the constant of integration is unknown, all it has to do is differentiate to 0 to get back to your original answer, so we don't really need to worry about it. So let's look at one more example, just to convince you it's not going to make a difference. Get rid of all of this stuff. Get rid of our rule, you should have written it down, Eric. Okay, so let's look at another example. Let's say the integral of pi x cubed plus 5 pi x dx. Okay, so clearly there's a common factor of a pi which I can take outside the integral sign. So it becomes the integral of x cubed plus 5x dx. And I can integrate all of that. So it'll be pi brackets x to the 4 over 4 plus 5x squared over 2 plus c. And just shrink that down, which expands out to give a final answer of pi x to the 4 over 4 plus 5 pi x squared over 2, and I could say plus pi c, but pi c is a little bit messy, so actually I'm just going to say plus some constant d and use a new letter, and that would be the final answer. Okay, so I hope that's helped you understand our original rule of how to integrate a function times a constant, and I will see you in tomorrow's lesson.